Hello, sixth grade. Welcome to EDM Lesson 610, Building and Solving Equations with the Pan Balance Model. Today, we are going to explore methods for solving equations, and we're going to be using a lot of the skills that you've already learned from this unit to do it. We're going to distribute, we're going to combine like terms, and we're going to use inverse operations. And so, let's take a look at our math message on Student Math Journal, page 295. It says, determine whether the two equations in each set are equivalent. Be prepared to discuss how you decided whether they are equivalent or not. So set A says that 4x plus 3x equals 21 and 7x equals 21, and we're trying to determine if these two things are equivalent. Well, that means we're going to have to combine like terms because 4x plus 3x, they're both variable terms, and so we can combine them, and 4x plus 3x is 7x. So 7x equals 21 and 7x equals 21. These are equivalent equations. Let's take a look at the next one. Set B says 3 times the quantity x plus 2 equals 7 plus x. Or the other equation is 3x plus 2 equals 7 plus x. I notice there is one slight difference, and it's these parentheses here. And that's the clue. The parentheses tell us, we need to distribute. So let's do a little work at the side. So we have 3 distributed to the x. So 3 times x is 3x. And then we have to distribute the 3 to the 2. 3 times 2 is 6. So in place of our 3 times quantity x plus 2, we're going to replace that with 3x plus 6. And now you can see that these are not equivalent because 3x plus 6 is not equivalent to 3x plus 2. Let's take a look at the next problem. X equals 5 and 5x equals 25. Are they the same? Well, we can find out if they're the same by solving for x. And so let's take a look here. We need to use inverse operations to find out what x equals here. Now, I know some of you in your brains, because your brains are good and fast, have already figured this out. But stick with me for one more minute, okay? We want to use the inverse of multiplying by 5, because that's what this means. This means 5 times x. And the inverse of multiplying by 5 is dividing by 5. And if we divide each side by 5, 5x divided by 5 equals x, and 25 divided by 5 equals 5. And so here's what we've got. We have x equals 5, and 5x equals 25 simplifies to x equals 5. And so, yes, they are equivalent. All right. So let's take a look at our next problem. Here we're going to be building an equation. We're going to make an equation, and that's going to help us solve equations. By looking at how they're built, we can take them apart and solve them. So here we have pan balances. And remember, the point of a pan balance is that whatever you do to one side, you have to do to the other to keep it in balance. And so on one side, we have x. On the other side, we have 10. X equals 10. And we're going to do something to each side, and we're going to build up an equation. So let's see what that looks like. So the first thing we're going to do is multiply by 3. We're going to multiply each side by 3. So 3 times x equals 3x, and 3 times 10 equals 30. Okay, so now we have 3x equals 30. The next step we're going to do is add 18. Now this is where we have to think about combining like terms. 18 is a constant term. 3x is a variable term. Constant terms may not be combined with variable terms. 30 is a constant term, so it can be combined with 18. So let's see what this looks like. When I add 3x and 18, since they're not like terms, they can't be combined. And so we have 3x plus 18, our variable term, plus our constant term. But 30 and 18 are both constant terms, so we can combine them to get 48. And it is a constant term. But we're still building our equation, so let's have one more step. Add 2x. There's that idea of combining like terms again. 2x is a variable term. Variable terms can only be combined with variable terms. So on the left-hand side, we can combine the 3x and the 2x. We'll get 5x. The 18 has to stay by itself because we cannot combine it with the variable term. 5x is our variable term. 18x is our constant term. On the right-hand side, we have 48, a constant term. It cannot be combined with our 2x because 2x is a variable term. And so they have to sit next to each other. 2x plus 48. 2x is our variable term. 48 is our constant term. So we've now built this equation. 5x plus 18 equals 2x plus 48. So now I'm going to show you how to work backwards to solve this equation. Remember, our goal is always to get the variable alone on one side of the equation so that we know what it's worth. So we're going to try to figure out what steps they took from each pan balance to the one below to solve for x equals 10. And you're going to see that they look very similar in some ways to the steps we did on the last slide. So from 5x plus 18 to 3x plus 18, you can see they subtracted 2x, or 2x less. On the right-hand side, we had 2x plus 48, and now we don't have any x's plus 48 because both sides had 2x subtracted. From our second pan balance to the third, we have 3x plus 18. Here we just have 3x. We were at 48 on the right, and now we're at 30. It looks like they subtracted 18. Now we have 3x, and we go to 1x, and 30, and we go to 10. Both sides have been divided by 3. In the middle school, you wouldn't have these pan balances. This is what it would look like if you were going to solve it in the middle school. So 5x plus 18 equals 2x plus 48. And the first thing you would do is, well, if we want to get the variable alone on one side, we got to get rid of the things that we can get rid of. From each side, we can get rid of 2x. We always get rid of the smaller variable term first. So if we subtract 2x from each side, we're left with 3x plus 18 equals 48. Now we want to get that variable alone, so let's get rid of a plus 18. The inverse of adding 18 is subtracting 18. Whatever we do to one side, we do to the other. And so we're left with 3x equals 30. And now, since we have a variable term and a constant term, we can't add or subtract. We must multiply or divide. We're trying to get down to x. We want to divide by 3. 3x divided by 3 equals x, and 30 divided by 3 equals 10. This is what your problem solving would look like in the middle school. But as always, always, always check your work. We substitute the solution for the variable. This is how you know all the time if your work is right. So if we think x equals 10, then wherever we see an x in our equation, we're going to substitute the number 10. And so our equation now looks like 5 times 10 plus 18 equals 2 times 10 plus 48. And this is where we have to remember GEMDAS, our order of operations. We have to multiply before we add. So 5 times 10 equals 50. So 50 plus 18 on the left. 2 times 10 is 20, so 20 plus 48 on the right. And if we add both sides, we see that 68 equals 68, and we know that we are correct. Let's take a look at the next problem. We're going to create another equation. They've given you the steps. If you think you can fill in our pan balances with each step, take a minute, pause the video, fill them in, then turn the video back on to check. All right, so let's do this together now. So let's start off with n equals 7, and it tells us to subtract 2. Well, remember this idea of combining like terms. 2 is a constant term, n is a variable term. And so we have to make sure that we do not combine them. 7 is a constant term. We can combine it with the subtracting 2. So n subtracted and then subtract 2 is n minus 2, because we have a variable term and a constant term. On the other side, 7 minus 2, well, that equals 5. It's just a constant term. Our next step is to multiply by 4. And we have to multiply the whole side by 4. And so this looks a little different. You'll notice that it's 4 times the quantity, n minus 2, because we're multiplying the whole thing. On the other side, we can do 5 times 4, and that gives us 20. For our last step, we have to add 2n. 2n, you'll notice, is a variable term. But we can't just add it into the parentheses here because these parentheses are multiplied by something. So we have to add it separately. So it looks like this: 4 times quantity n minus 2 plus 2n. On the right-hand side, we can't add 2n to our 20 because 20 is a constant term. So it looks like 20 plus 2n. And so here we have this long equation, and we're going to see if we can solve it. If you think you know the steps for solving this equation, pause and write them in, then come back and check on the video. Okay, guys, let's take a look at this. So here we have 4 times quantity n minus 2 plus 2n equals 20 plus 2n. And we want to see what happens from our first to our second pan balance. Well, guys, our goal, remember, is always to get down here to get that variable alone on one side. So in this top pan balance, I see a plus 2n on each side. Then the second pan balance, that's not there. So they must have gotten rid of it. Well, to get rid of adding 2n, we use the inverse, which is to subtract 2n. All right, that makes a lot of sense. Let's take a look at our second and third pan balances. In our second pan balance, I have a times 4 before my n plus 2. I don't have it in my third pan balance. And so I think that they use the inverse here to divide by 4. And that seems to be backed up because 20 divided by 4 equals 5. Let's take a look at our third to our fourth. Here I have n minus 2, and here I just have n. That minus 2 is gone. On the other side, I have a 5, but now I have a 7. That got greater. So the inverse, to get rid of a minus 2, we would have to do the inverse, which is to add 2. That makes sense because 5 plus 2 is 7. So I think we got this right. But as always, we need to check our work. We substitute the solution for the variable. If we think n equals 7, we're going to substitute the number 7 every place we see that n. So our problem becomes this. Our equation becomes this. 4 times quantity 7 minus 2 plus 2 times 7 equals 20 plus 2 times 7. Oh boy, don't forget your order of operations, your GEMDAS. That says we have to do grouping symbols first. So the first thing we will do down here is 7 minus 2, which gives us 5. Then we don't have any exponents, so we're going to multiply. Okay. 4 times 5 is 20. 2 times 7 is 14. 2 times 7 is 14. And so we're left with 20 plus 14 equals 20 plus 14. And each side equals 34. If both sides are equal, we know we're correct. So let's take a look at this equation. Pause the video and see if you can figure out the steps that they use to solve this equation. Remember, the goal is to get the variable alone on one side of the equation. When you've finished, unpause and check your work. Okay, guys. So if we take a look at our top bar, or excuse me, not bar model, pan balance, we have 3p plus 6 equals 10. Down here, I just see 3p and I see a 4. It looks like they subtracted 6 from both sides. And that would make sense because the inverse of adding 6 is subtracting 6. And 10 minus 6 equals 4. To go from our second to our third pan balance, we go from 3p just to 1p and 4 to 4/3. Remember, anytime you see a fraction, guys, another way to read that is as a division problem. So this could be 4 divided by 3. And that gives us a clue here because 3p divided by 3 equals p, and 4 divided by 3 equals 4/3. If we were to do this in the middle school style, it would look like this. 3p plus 6 equals 10. And our goal would be to get the variable alone on one side. So we want to get rid of all the stuff around the p. So to get rid of a plus 6, we would use the inverse, which would be to subtract 6 from each side. Whatever we do to one side, we do to the other. And so we would end up with 3p equals 4. Remember, since our goal is to get that variable alone, we want to get this times 3 out of here. Well, the inverse of multiplying by 3 is dividing by 3. And if we divide each side by 3, 3p divided by 3 equals p. And 4 divided by 3 equals 4/3. Let's check and see if this works. Remember, we would substitute the solution for the variable. So if P equals 4/3, then we would substitute 4/3 in for the letter P. And it would look like this. 3 times 4/3 plus 6 equals 10. Don't forget your order of operations. That means multiplication comes first. Oh man, it's been a little while since we've done this. 3 times 4/3. Remember, our 3 has a denominator of 1. And so we would get 3 times 4 is 12. And 1 times 3 is 3. And 12/3 is really a division problem. 12/3 is 12 divided by 3, which equals 4. Okay, so 3 times 4/3 is 4, plus 6 equals 10. And we know that's true. 4 plus 6 is 10. 10 equals 10. This works. We have it correct. All right, guys, so let's wrap it up here. Remember, your goal every time is to get the variable alone on one side of the equation. Okay? You may need to distribute. You may need to combine like terms. You will definitely need to use inverse operations to solve these equations. Okay? Always check your work by substituting the solution for the variable. Hope this helps. Rewatch the video if you need more help, and do a good job on your work. Bye, guys.